Hello, everyone. It's great to be here today. Like he mentioned, my name is Necoline Hubner. I live in San Francisco. That's where my nonprofit is based out of. And before that, I was working for Google. And before that, I'm not originally a developer. I started out working with refugees on the resettlement side. So when I was able to combine my work with technology and refugees, it was really exciting to be able to combine my interests and my passions all in the same place. RISE is a nonprofit that works in refugee camps to create solutions using technology. And we're focused specifically on improving attendance for girls in schools. And there's a lot of programs that currently exist to help out with this particular issue. And what we're interested in is learning how things are working and how things can be improved with the use of technology. They have, through these large organizations, large software programs to help out with coordinating work. But as soon as you get into the field, there is a limited access to general infrastructure. So people resort to pen and paper mechanisms to keep track of the work that they're doing. So I just spent the last month in Kakuma, which is a refugee camp in the north of Kenya. And I was interviewing teachers and aid workers to get an idea of what they do and what works and what's challenging for them. And one thing that they said is that they've got a meals program where they work with the World Food Program and they provide porridge to girls, well, to all the children that attend school. And this is greatly increasing the rate of attendance for them. And they're able to see the correlation between offering food and attendance. But generally, when it comes to tracking attendance and the effectiveness of this program, they are taking attendance on something that looks like this, where they'll take attendance and write it on the chalkboard, and someone will come around and take the total and go from class to class, adding everything up, and then bringing it to admin and then to the kitchen, where they can decide how much they're going to make for that population. If they're lucky, they might have a laptop per school where they're able to keep track of everything in an Excel sheet. If they're not lucky, they'll keep meticulous notes on these paper sheets and then do iterations off of that and send them to headquarters where they then do the data entry and the analysis. So as you can imagine, it's a pretty arduous system that they have to deal with, and it's very time-consuming. And when they have other large problems with child protection and general education for refugees, you can see how it might become something that falls into the background in the work that they're doing. So we're building a mobile app to track attendance and the effectiveness of the meals program in Kakuma. This means that it has to work in the environments where technology that's coming from these larger organizations hasn't been able to penetrate. So in Kakuma, it's a very rural environment. It's incredibly remote. It's right next to South Sudan and Uganda. The people there use many types of devices. They're usually quite old. And they have intermittent access to Wi-Fi and general connectivity. Although I will say I was very surprised at how widespread connection to service was. I had about a 3G connection everywhere that I went in the camps. So you have aid workers and refugees that rely heavily on their phones to be able to communicate with each other and use apps that are available to them. The only issue is that there's not a lot of things that are designed specifically for their purposes. So they patch together different apps to network with each other and solve problems. So in order to solve the issue of how to provide technology for this population, there's a lot of fascinating topics to jump into. Things like performance, making sure it's as lightweight as possible and that it's running on as low of bandwidth in a way that is fluid and is still working for the client is very important. Battery usage is a huge portion of our interests. A lot of the refugees don't have access to power at all, so they'll actually go into town and pay a little bit of money to charge their phones. So making sure that we're considering for that, as well as responsive design, because it has to be device agnostic. But what I want to talk to you guys today about is actually offline capabilities and how it pertains to service workers. So the first question when developing for the next billion users or a population such as this is, are service workers right for you and your user base? So for us, there's a huge incentive to use service workers to offer offline capabilities. However, and this is a big but, the devices that are being used in the camps might dictate their ability to access these capabilities based off of what kind of operating systems they're working with and whether or not they have access to browsers that are compatible with service workers. So we did some research into what kind of devices are most commonly used. So most aid workers are Kenyan nationals, and we have refugee incentive workers who also work in the camps. So looking at the Kenyan market share is a pretty good indicator of exactly what's being used. As you can see, there is a pretty clear division in types of devices. The red line is Android, and then if you can see the gray line at the bottom, that's iOS. So that's a pretty nice marker. We know exactly, for the most part, what people are using, which are Android devices. So we looked then at the operating systems that are being used, and you have a bit more of a mixed bag here. So in order to access modern browsers like Chrome for Android, you need an operating system of at least 4.0 or higher. That's ice cream sandwich. And so you can see I'm looking at about 50% of users that have that level of operating system. And one big learning curve for me, I live and work in Silicon Valley. I have my MacBook and my Google Pixel, and I forget what it's, or not forget, I don't know what it's like to use the web in environments that are not my own. And one thing that I learned is that if you buy a cheap phone, like a smartphone for less than $100, the manufacturers don't have an incentive to provide support after the purchase. So they're looking for people to rebuy the phone later on if it becomes out of date. So that means that there's not a lot of updates for operating systems after the purchase of a phone. So if you buy a phone that has an old operating system, it's likely to stay that way for the lifetime of that phone. Another caveat is that a lot of the refugee workers that we're looking at are likely to represent the lower half of this chart. So despite being really excited about service workers and how this can apply to making the lives easier of my user base, understanding exactly how far-reaching it is a huge aspect of what we're doing. I would normally show Can I Use chart, but there's a site called Is Service Worker Ready that gives a more nuanced look at what browsers are able to do and what compatibility levels for different service worker APIs. So this is the baseline for service worker compatibility. You can see there's a pretty wide adoption, but depending on what exactly you want to do with your service worker, the browser compatibility will be a little bit different. So due to the fact that there's a significant portion of my users that are not going to be able to access service workers, but generally as it pertains to the ethos of service workers, they are a progressive enhancement. So talking about them in terms of progressive enhancement is really essential to the development process of working with offline capabilities. So it's really not about a technology choice. Progressive enhancements are about a development approach. It's the idea that you start out with a solid foundation of what kind of experience you want your users to have, and then you add consecutively on top of that experience as you understand that your user base will be able to actually access the enhanced experience that you provide to them. So you can consider the ice cream cone. If you have a great waffle base and an amazing quality of ice cream, you're not going to mind too much whether or not you have toppings on top. So defining the baseline of support for your users and the core functionality is key in the development approach of progressive enhancements. And then once that's established and once that is done well, then we can add things through iteration and improvements, adding exciting things like prefetch content and push notifications. So ultimately, we want to make sure that we're building for all of our users. So if you decide that service workers are what you're going to work with, and for us, we decided that it is something that we're still very excited about, so we can talk about what exactly service workers are. Offline capabilities are not new to the advent of service workers. There's actually something before service workers called app cache or application cache. And this was, or is a declarative API that would allow you to cache static assets or specific assets. And it was really good if you were using it for the specific purpose that it was designed for. And if you wanted to do literally anything else, it would break your whole app. So the internet is full of scathing reviews on app cache. I think if you used it the way it was meant to, it's not that terrible. But here, MDN has a review of why service workers win over application cache. And ultimately, it's because you have a granular control over the work that you do, and you have a lot of options available to you. So what is a service worker? It's essentially a type of web worker that runs on a JavaScript file, and it sits between the web page, the browser, and the network. And it allows you to intercept and modify navigation and resource requests and cache resources. So the most obvious application of this is to serve up cached resources when there's no access to the network. And because this runs in a worker context, it does not have access to the DOM, and it runs on a separate thread, so you never have to worry about it blocking your app. So when done right, and when you have a full comprehension of what service workers can do for you and how they work, they provide a lot more than just offline capabilities. They can do things like push notifications, background syncs, local downloads. They can act as a load balancer, which is pretty cool. You can create a virtual server with service workers or conduct API analytics. When it's not done right, or if you don't have a full understanding, it looks a little bit more like this review of service workers, which is essentially a web worker that allows you to run very old versions of your app without anyone noticing for months and months. And the reason for this is that there's a lot that goes behind getting a service worker running and getting a new service worker replacing the current service worker in a fashion that is effective, and it's really easy to get stuck. So for the remainder of the talk, I want to talk about how you can get into service workers and overcome some of the initial pain points and just jump in without having to deal with the headaches that are usually incurred through service workers. And the first major hurdle is understanding the life cycle of a service worker. It's not that complex, but there's a lot of room for failure as we get to the point of getting it to the running stage. So the first thing that has to happen is it has to be parsed and registered. Parsing means that it will go through a system where you check the requirements, making sure it's obviously compatible with a browser. It has to work over an HTTPS connection, has to be secure, which makes a lot of sense. And it will be registered if a service worker has not been registered before, and if the service worker that you're trying to register is different than the service worker that's running. And it evaluates this by bytes. So if it's 1 byte different, then it will acknowledge that as different and continue with the registration process. If it fails to download or parse, or if it throws an error at this point, the service worker will simply be discarded. If it is successful, it means it's been registered. It doesn't really mean anything else other than that. So the next stage is installing. So after it's successfully registered, the script is downloaded and the browser will attempt to install the service worker. This is an ideal point where you would cache your static assets. Now, service workers run on promises. So if the promise does not return successfully, it usually has something to do with the dependencies that are included in this asset caching. So this is one of the first things that you might look at if it becomes an issue and you don't get a successful return of a promise. If it is rejected, the service worker at this point enters into its final stage of life, which is a redundant service worker. If it is successful, it goes into an awaiting stage. Awaiting is a very important stage because it's how the browser controls that there's only one service worker running at a time. Only one service worker can control the client for obvious reasons. And it's recommended that you never force activation, because if the service worker is a very different version than the current service worker that's running, it can completely break the client. So at this point, you might consider prompting the user to refresh their page so they can access the new content that you're providing to them. So activating happens if there's no service worker that has already been registered. If you elect to skip waiting, it will jump into that. It's not recommended that you do this unless it's a first-time registration. If the user navigates to a new page or refreshes, that will instigate activation. And then if the existing service worker times out, then it'll usher in the new service worker because it's no longer controlling the client. If there's an issue here, like if you decided to skip waiting and there was an issue, it will also become redundant at this point. If you make it through that successfully, then you get to the activated state. And now we get to the point where the service worker can control the client and can accept functional events. And this will come through like the fetch API or a message. And it will wait for these functional events in a state called idle. And if it doesn't receive any functional events, it will go into a state called terminate. Terminate is not redundant. Terminate will just jump back into idle as soon as it receives any functional events. The reason for this is that the service worker does not run until it needs to run, and this preserves bandwidth for us, and it's really good for performance. So it's excellent that it does behave in this way. So redundancy is what we want to avoid. It can happen if there's failure at installing, activating, or if it ultimately phases out and gets replaced. So you can see it's a bit of a treacherous journey for the service worker to make it all the way through a successful completion of a life cycle. Other tips for starting is getting to know the browser before you start working with service workers. So understanding your dev tools is going to be very helpful. This is where we're going to inspect the service worker, do our error handling, and also setting the defaults. There's this thing called update on reload, which allows the service worker to behave in a way that you are used to as a developer, being able to interact with the DOM, where if you click refresh, you expect to see your changes. This is something that you have to go in and click currently as a default. It's good because it means it makes you aware of the lifecycle. However, it's really important just to know what defaults you want to set and know exactly how it's behaving. So taking the time before you get into service workers to understand your dev tools is going to help you develop a strategy for combating all of the bugs that you're probably going to address later. Next, as I mentioned, service workers are built on promises. So if you're not strong on promises, this is a great opportunity to jump into it. You'll have a lot of practice when you work with service workers to get into promises. If you are comfortable with promises, then consider adopting async await. This is essentially syntactic sugar on top of promises that allow you to just write cleaner code, it's better error handling, helps you write conditionals, and it's just a much better experience. There's a little bit of cognitive overhead, but it'll save you a lot of stress in the future. The next one is ways to not get stuck on the same screen. So having a cache and validation strategy is going to be very useful in predicting how to solve the problems that you know you're eventually going to face. So something that you might consider is having a feature flag to control unregistration. It's not the same as forced activation. You just simply unregister the currently working service worker. Another option is having a no-op service worker, which is essentially a service worker that you'll have at the ready for an emergency deployment in case that there's an issue, and this will just be something that will delete your cache but not have any fetch. So it give you a fresh restart if things get really messy and you need to have a quick save. And lastly, having a force update for version control will be really useful, where you can just fire off a method that will get the service worker to check to see if it's on the most updated version and then update itself if it's not. And last, there's a lot of resources that are available to get started with service workers. Having a core conception of what service workers are before you jump into generator tools will help you with understanding what you want. But Workbox is a really great tool that offers things like pre-caching and runtime caching, as well as strategies, which are endless in ways that you can address different techniques to accomplish the things that are available through service workers. Cookbooks are also available. Jake Archibald is like the father of service workers. He's got an offline cookbook, which is worth a read, whether or not you're looking into offline capabilities with your service workers. And then Mozilla has a service worker cookbook that goes beyond offline. So all of the extra things I was mentioning about like load balancers or working with your API, that all comes from, well, I was inspired at least from Mozilla's cookbook. It's really a nice way to integrate your ideas into something that's a little bit more broad in its application of service workers. So that's my talk. I hope that it was useful in being able to understand how you might get started with service workers. I have all the resources on my slides, which I'll be posting, so feel free to follow me on Twitter or on Instagram. And I think we have some questions. Thank you.
Let's give it up for Necoline.
Thank you.
Fantastic. All right, a couple of questions. What dev tools are you using for service workers? The Chrome dev tools are super awful to use when handling cache, IDB store, and service workers.
I've been working with the Chrome dev tools, and there's a lot of work to go with it, but I would suggest just getting involved in the community and letting people know what your frustrations are with the dev tools, because I think they're quite active in trying to help people understand how to use them and understand what your frustrations are as well. So that's kind of the definition for me of like what's working. And I know Firefox has its own dev tools as well, which is worth looking into. But I don't know. It's a journey. Yeah.
All right. Are you using some library or are you writing SWs from scratch?
I elected to write them from scratch. I've toyed around with Workbox. However, because of what we're doing with our app, I'm trying to make everything as bare bones as possible. So it's possible to do it from scratch. I know Create React App does some service workers out of the box, which is really, there's a lot of support around how to make that work. Personally, I just like to get as basic as possible to help me in my own learning process. But you don't have to do it that way. Yeah.
Fantastic. All right. In your case, what is the main reason to do web app using service workers instead of native app?
That's a really good question. For us, it's about capacity. To be able to design for something that goes across devices is really important. We want to be able to access as many users as possible. So being able to do a web app allows us to cross between not only iOS and Android, but also tablets and desktops. We want to be as versatile as possible due to the work that we're doing and not get pigeonholed into working with native apps, even though there's a lot of perks with going that route. Yeah.
All right, we've got an altruistic question from Carol. How can we help?
Hit me up on Twitter and I'll let you know. We're looking to make this open source. We haven't gotten to that point just yet. We're in the design phase and building out the baseline. But yeah, we'd love your input. We'd love your help. It is a nonprofit. You can also donate. So I'll have all of that available as well. So good question. Thank you. Yeah.
Thank you, Carol. All right, last question. How do you distribute the app to users? Via App Store?
Well, because we are working in the camps themselves, the distribution is a little bit unique in the sense that there's a lot of building up of trust and networking with the existing agencies. So a lot of it is actually through like a top-down approach. So we're not looking for organic adoption at this point. So it would look different than it would for other apps. We're actually going into the camps and handing it to them and training them on it. So,
All right, let's
yeah.
give a warm round of applause for Necoline.
Thank you.
Thank you very much.